Hello, ladies and gentlemen. How are you? I'm back again with a new session, and today I'll explain you file system permissions and what's it all about. I think in order to explain you, I need to explain you some Boolean operations. Just follow me. So if you haven't, Boolean operations. So Bool means. Is related to binary, and binary means 0 or 1. So a Boolean operation is 0 and 1 operations. So we have some relationships called AND relationships, OR relationships, XOR relationship, NOT. So what it means is that everything at the end of the day is in electronics is 1 or 0. And I'm really going fast with this, but just follow me. So if there are 2 bits, if they are so the AND is represented as, let me show you, AND is represented as something like this. So if 2 inputs are coming to an AND gate, AND relationship right here, they will give you an output here of 1. Okay, how is that possible? So AND relationship follows. So let's say if this input is X and Y, so we call it, we call something called truth table. So you have X and Y, and you have result or function. Okay, results F. So result is something that's coming out here. So this is let's say this is results, right? So any output, or you can simply say it's an output. So when X and Y passes to an AND gate, it results in output. So there is a common, so if you have 2 inputs and each input can carry 2 possible values, 0 and 1. So there are going to be 2 raised to the power n possible results, right? So in this case, n is the input, right? Number of inputs. In the example above, we have 2 inputs, X and Y, which is having values of 1 and 1. You can think of this as, let's see, this is X and Y. So X and Y are the binary variables, and they can the possible values are 0 or 1. So if the values are 0 and 1, what is 0 or 1? What is going to be the what's the possible results if once they pass through this AND relationship or AND gate? So this AND is actually a Boolean operation. So for that, we build something called truth table, and truth tables are known as, so we say that, okay, we put all possible inputs and then results. So X can have a value 0 and Y can have a value 0. In this case, the result's going to be 0. So X can have a value 0 and 1, and the result's going to be 0. For AND relationship, anything, if in order for the results to be 1, or both the input has to be 1, otherwise it's all going to result in 0. Okay, now this is not anyway equivalent to multiplication, but it sounds like that. But so this is the truth table for an AND relationship. So we say that if 2 possible inputs are 0, any possible inputs, unless all the inputs are 0, the results cannot be 1. So as you can see, it's very evident. Okay, now let's clone this and formulate that to, let's see, I'm having a hard time. So the other relationship we have is an OR relationship. OR relationship means you need at least one input to be 1 in order to get the result 1. So in this case, only one scenario when the results can be 0 is that when both the inputs are 0. Okay, so this is totally opposite. Okay, in this case 1 1 1. So you can see that if all the inputs are 0, results are 0. Okay, so that's the relationship, XOR relationship. Let's go to the XOR relationship. XOR means even cancels out. So if there are odd number of ones, it will result in 1. So even cancels out. So even. So 0 0 has to be 0, and 0 1 is going to be 1 because it's odd. Number of odd is 1, so it's 1. These two, 1 and 1, they are both 1, so they're going to cancel out and it will be 0. Sorry. So that's a very important. The CRC, we talk about CRC and cyclic redundancy checks and everything. Internally, they use XOR operations. Okay. And what is a NOT? The last thing, the NOT that we want to talk about. So it's little. So NOT, you can explain that with one input. You probably don't need both the inputs. So let's get rid of one. So it's actually a flip. So in a NOT relationship, any bit that has a value, when it goes through the NOT, it flips it, right? And it becomes X NOT. Okay. What that means, if 0 passes through the NOT, it's an inverter, which means it will invert the bit. So it goes to the NOT, it becomes 1. Similarly, if it goes to 1, it will flip to 0. So this is the basics you need to understand. Okay, let's get to the file permissions. File permissions in a Unix file system is something like this. Okay, so every file has an owner and group permissions, and it's all for all users. Okay, so there's another bit in the beginning which is called additional bit, which is on the prefix side. So there are actually 10 bits, but the first bit is called the parity bit. So let's worry about that later, but let's see how the operation works. So the owner has 3 bits so attached to it. So you have X, Y, and Z, and similarly group has X, Y, and Z. Okay, and all users have also possible X, Y's. Okay, so what can be the possible values? In this case, every group, like owner group and all users, have X, Y, Z 3 bits. So what are the possible values of this? And they are all binary. So it's 2 raised to the power 3, which is 8 possible combinations, right? So what are going to be the combinations? 8 possible combinations. 8 possible combinations means either the owner has 000 or 001 or 1010, 011, 1. So it's like 03, 4, and then they have this is all binary equivalents of 0, 1, and this is 1, 1, 1. So this is 0, this is 1, this is 2, this is 3, this is 4, this is 6, and this is 7. Okay. So it means, so what is the first bit? So actually, it's not XYZ. Actually, the first bit is called read bit, the other is write, and X is execute. So read, write, X. I was just giving an example. So in reality, read represent the first, write represent the second, 0, 0. When a bit is 1, that means that value is true. That's on. So so that is how the permission works. Okay, so if let's say if all the bits are 0 for the owner and all the bits are 0 for the owner, and if all the bits are 0 for this, so this permission is simply the file will have a values like this. Let's say if RWX is all 0, right, for everything, so the permission is going to look like okay. If you want to simulate this on the file system, the permission will look like this. First 2 bit are off, the first bit, last bit is on, so it will be called X here, and let's say if everything else is, it will be this. Okay, what about this? If the last one, if every bit is on, and let's say if it's true for all the type of users, owner, group, and users, so that means the read write X is on, then you have read write X is on, read write X is on. So technically this means the value of this is 7. So the first combination will be 7. This is also called 777. Okay, this is called called 6 6 6 if all of them is 110, right? But they can have different values. Let's say if this is read write on this one and this is X, and let's say the group has read only, okay, and then all has read only, then it means the first 2 bits are on, so this is going to be 6, this is going to be 4, this will be 4. This will be treated as 6, because you have 2 bits on, and if you have 2 bits on, it's 6, right? And if you have 1 bit on, it's equivalent to 4, right? Because there's 1 bit on, so it will be 6 for the first set, and 4 for the other, 4 for the other. Okay, so this is how the file system works. Okay, let's get on, and so let me explain you. I'll give you a live example so you can relate. Let's see, I can take you down to a system. I really don't need to log into the system, but for the sake of clarity, I will. I'm logged into my system. So now take an example of test keys, right? So we'll look at this permission. The first bit is a special bit, so leave that. But the rest of the bit is like this file. They take an example. What is the equivalent of this? Maybe copy this and paste it here. Let's learn from here. What is the permission of this? So this read write X, this is the owner part, this is the group part, and this is the all users. So this all bits are on, so this is 7. The read is on, but the write is off, execute is on, read, write is off, and execute. So the first one is equivalent to 111. The second set is 101, and the fourth set. So it's actually 755. That's the permission for this. Okay. I hope you understand this and are able to process this. We are getting a little deeper slowly. The next section I can show you how can you change the permissions of this and what commands are used. So I can explain you the 2 commands that are related to file system permissions, so ownership and permission. So one's called chmod, the other is called ownership chown. I would like you to go and look into how chmod and chown works. Go ahead and read the man pages, and I'll be back with you. Thank you very much for stay tuned, and we'll keep learning. Thank you.